right, so this video is a review of or a lesson on the things we did in class. Let's say Friday, April 8th, and this is the worksheet that we're talking about is SAT review and it's angle rules. All right, so it's worth noting that every SAT will come with this reference page over here on the left. It's on your worksheet. It's kind of hard to see. The only two things you really need for this worksheet, if we zoom in, are the two that are highlighted. Right, there are 360 degrees in a circle, 180 degrees in a triangle, right? Those two things. So when we look at example one, we're going to use that fact about the triangle, right? Now, the question is talking about this angle. We're supposed to find x. But first, we have to find two other angles. So first thing that we can say is that right here, these two angles are on this straight line, right? And a straight line also has angles that add up to 180. So if they add up to 180, then that means this angle would have to be 66 degrees. So then from there, the next thing to figure out is the last angle within this triangle. And so if we know two of the angles on the inside of a triangle, then we can find the third, right? We can take away both of those other interior angles and figure out what's left over. So let's see, that'd be 98 minus 66, it's 32. And then we use the same thing that we used on the first example. So we have one angle left, and it's on a straight line along with 32. So if we do that, let's see, so 180 minus 32, it's 150, 148, which seems to make sense, and it bears keeping in mind that most of the drawings on the SAT look pretty much as they are. All right, so on to the next one. Here's the next thing they tell us in the top right of that page. Talks about parallel lines, right? And in here we can see that the vertical angles like this, A and D, we could say A equals D. We could say B equals C. And then down here we could say this, B is equal to F. And we could also say A is equal to E. Now follow along, and then E is equal to H. Now all these things are true, and if you look at number 4 on your worksheet, if we go to the back, let me zoom out. Let me go to the next page. Number 4 has something that looks a lot like this. And it's saying, what about B plus C and D plus E? Which of the following is true? And I'm going to use these facts about these vertical angles here, right? So if I'm doing that, I could kind of make a little train here. A is equal to D, but A is also equal to E. So I could say from here and here that D is equal to E, right? And I could say since B is equal to C and B is equal to F, then I could say C is equal to F, right? And then number 4 is asking about what if you add them up, right? Well, I know here that A plus B is equal to 180. Think about for a second what else that could tell you, right? Well, wouldn't that mean that E plus F is also equal to 180? And then what if A is equal to something else? Can I replace it? Well, yeah. If A is equal to D, then I could say D plus B is equal to 180, and so on. So think about that when you do number 4. The next thing we're going to see is an isosceles triangle. Isosceles triangles have two congruent sides. They also have two congruent angles that are opposite from each other. Okay, so looking at example 2, we're going to use that idea. Remember, drawings on the SAT usually look as they are. So they are typically drawn to scale. So these two are about the same. They look the same, and they tell us that they're the same. AD is equal to AE. They also tell this down below. They say that AB and CD are parallel. Whoa. Sorry, AB and CD are parallel. They also tell us that these two lines are parallel. So what we actually have outlined in the blue is a parallelogram. And one thing we know about parallelograms is that these two angles are equal to each other. So that means this is 95. And the goal of the question, before I get too far, is what is the measure of angle ADE? So when we label angles, we label them like this, ADE, right? As we say it, you can draw it out on the paper. So you are asked, to figure out what this is right here. Keep in mind that this angle is the same as that one. And these two should add up to 180, right? So 180 minus the 95 that we already have is equal to 85. Since this is 85, then that means this must be 85, and we're done. Okay, the last one that I'll do for you is kind of tricky. It's number 3. It says in the figure above, what's the value of x? All right, a few things to realize. Even though it's a very funky looking one, this is a 1, 2, 3, 4-sided figure. Okay, that's a quadrilateral, right? Quadrilaterals have 4 sides, and they have a total of 360 degrees on the interior, right? Triangles have 180, quadrilaterals have 360. Now, this is a really funky looking one because it's caved in. This is called a concave polygon. So it's very weird. It has an angle that's bigger than 180 because it's caved in like that. So here's the key to this question. We know that we're trying to find x. These three are all the same. So if I can figure out what this angle is here, then I can figure out what all the others have to be. So this angle here, we have to think of like a circle. So if I kind of just sketch a circle around this, right, then I really have, I'll sketch it off to the side. There's an angle, and we already know that this is 156 degrees of the whole circle. So the other piece has to make the two add up to 360. So if we do that, 360 minus 156, that's 204 degrees left over for that angle. And again, it's really funky. But if that one's 240, then all the other three are the same. So let's see what's left. 360 minus 204. Well, think about what we just did, right? We're using 360 because it's a quadrilateral, but we just did this. So that is 156, right? And if there's 156 degrees left in total for, again, these three x's, we can divide by 3. So x must be 52. All right. If you have any questions, feel free to holler. That's all.